So we spent yesterday solving all kinds of linear equations, and we know if you get a solution, what kind of equation is it? If you get
it's one solution.
a conditional, yes. If you solve the whole thing and have like 5 equals 3.
Contradiction.
That's a contradiction. There is no solution. What if you solve it and you get 5 equals 5? That's the identity. Your solution then is all real numbers. Okay, so we are starting everybody's favorite topic. We're looking at some word problems today. Yay! Don't all cheer at once. Okay. Woo! It's exciting stuff. Because in the real world, most of the time people don't just hand you a math problem to solve. You have a scenario and you have to kind of figure out how to get your solution. So this is more like what you're actually going to encounter. All the problems I'm doing today, they're word problems. I didn't print notes for you. However, you don't have to copy the whole thing down. If you were to go to Google Classroom, I have posted a handout with all my examples typed up. So you might just write a note to yourself at the top of your notebook page, examples on Google Classroom. And then if you're looking back in your notes, you can pull up that document, and that way you don't have to try to copy down all the problems as I'm going through them. Now, I'm going to be kind of picky about how we solve these problems. So our steps, and if you are looking at Google Classroom, it says section 1.6 examples, and this is listed at the top. So whether or not you write these down, that's up to you. It is on that handout. You always have to identify your variable. Okay, if you are solving a problem with x, I have to know what x is, and you have to know what x is, because we're going to encounter problems where we are looking for a couple different things. And if you don't know which one you made x, then when you get to the end, you won't know what your answer means. So you have to identify your variables. That could be, you tell me in words, x is whatever. It could be you draw a picture and you label x in that picture. So it's kind of depends on the problem how we might do that. But somewhere we need to tell what the variable is. Second thing, we have not talked about systems of equations yet in here. So I don't want to see a problem with an x, y, and a z. We want problems with one variable. So if there is something else we don't know, we have to put it all in terms of one variable. Okay, so maybe the first one's x and the second one is x minus 5. But I don't want to see x and y. Third step is setting up a model. That is writing your equation. Okay, that's how we are going to go about solving our problem. Fourth step, we need to solve it and check to make sure our answer is reasonable. You might have a problem where you get a negative, but if you go back to your problem, a negative wouldn't make sense there. So you need to make sure your answer suits the problem, that it is reasonable. And then the final thing, my rule, if I give you a problem in words, you have to answer it in words. So I don't want you to end with x equals 4. I want you to write a sentence answering the question that I asked you. There's a couple easy points on these. Even if you did everything wrong, if you identified your variable and you wrote a sentence at the end, you get 2 points automatically. Okay, so easy things, but on the flip side, even if you got the right answer on every problem, if you didn't do those things, you're automatically missing 2 points. So there's some easy points on this, but you have to make sure you're doing it every single time. Let's look at a problem. So what I found is when I give word problems, people look at it and they say, okay, if the length of each side of a square is decreased by 6 centimeters, the perimeter of the original square is 8 less than 3 times the perimeter of the new square. And they look at me and say, I don't understand what that said. And I just read it to you and I don't understand either. So you gotta slow down. You can't just read the whole problem. get to the end and think you're going to know what to do. We're going to go back, we're going to take a piece at a time. So, if the length of each side of a square, let's stop right there. The length of each side of a square. What could I do right now?
Draw a square.
Let's draw a square. All right. Is decreased by 6 centimeters. So what's happening to my square? It's got smaller. So this is the old square, and now I'm going to have a new square, and each side has been decreased, so it's smaller. Okay, did I tell you how long the sides were in my original square? So what should I do? What could I call this?
X.
X. We know it's a square, so we know all the sides are the same. So my old square, I could call those sides X. That's identifying my variable. Now my new square, I don't want to call my sides Y because I don't want multiple variables. But it told us it was decreased by 6. So what does that mean?
X minus 6.
Okay, so the new one we subtracted. All right, let's go back and keep reading. The perimeter of the original square. What is perimeter?
All sides.
Adding up all the sides. So you could write it as x plus x plus x plus x. Or we could just say, okay, there's 4 of them. So it'd be 4 times x. So either way, so that's the perimeter of the original. When we are writing equations, what does the word is mean?
Equal to.
8 less than. So does that mean 8 minus something or something minus 8?
Sometimes always minus 8.
3 times the perimeter of the new square.
X minus 6. 3 parentheses X minus 6.
Okay, so 3 times the perimeter of the new one. How would I get the perimeter of this? Okay, so the perimeter of that one will be if you added up all the sides, or you think of it as multiplying by 4. And we need 3 times that. So let's stop right here. We identified our variable. We put our other one in terms of the same variable. We have set up a model. We wrote our equation. Are there questions on anything I've done so far? Now this is like a problem from yesterday. We can solve that equation. So we have 4x equals, if I look inside here, this would be 4x minus 24. So now we need to move our 12 over. So subtract 12. Divide by -8. And x is 2. Am I finished? No. We had a word problem to start, so we have to answer in words. Go back. The question is not always going to be just what is x. So we have to look. The question wants the length of a side in the new square. The new square, the sides are x minus 6. So x minus 6 would be 4. So the sides in the new square are for, what were my units here? Centimeters long. Is that okay? Let's look at another problem. A rental car company charges $20 per day and 30 cents per mile for renting a car. Janice rents a car for 3 days and her bill comes to $72. How many miles did she drive? Alright, so is this a problem where I would just be able to draw a picture? No, that really wouldn't make sense here. So I can't define my variable with the picture, so that means I just need to do it in words. You can pick whatever letter you like. I tend to always use X, but there's nothing saying it has to be X. Pick your favorite letter. But what is the thing we are trying to find? How many miles? So my X is going to be the number of miles. And I decided that really by looking at the question. How many miles is what I needed, so that's what my X needs to be. Okay, is there anything else we're trying to find in this? No, so there's no other unknowns. So we did step 1. Step 2 doesn't really apply here. There's nothing else we don't know. So step 3, we have to write an equation. So the company charges $20 per day, 30 cents per mile. She rents the car for 3 days. Her bill is $72. Where am I going to start here? Okay. We pay $20 every day, and she rented it for 3 days. So we'll have 20 times 3. So we have to pay that $20 each of those days. And so we need to add on the cost per mile. Why did you do a decimal here? Right, 20 is in dollars, so we need to make sure the 30 cents has our decimal. And that's for every mile, so you'd have to take that times the number of miles. And that would equal our total bill, which was $72. Alright, so if we solve this, subtract over the 60, divide by 0.3, and we get 40. I'm not done yet though. What do we have to do? Write a sentence. The question was, how many miles did she drive? So we can say, let's see, Janice drove 40 miles. I'm going to put the next problem up here, and I want to see how far you guys can get. So I want you to take your time, read it, see if you can draw a picture describing the scenario, and see if you can write the equation. I don't want you to go ahead and solve it yet, just in case we have a mistake, but see if you can set it up, and then we'll double check how we did on that. It looks like most of you tried to set this up by drawing a picture, which is great. It's not required. So if you are not as much of a visual person and you don't need the picture, that's all right. That's not an essential piece, but somehow you have to define your variable, whether it's through the picture or through words. So what I know is he's painting with watercolors on a sheet of paper that's 20 inches wide and 15 inches high. So here's my paper. I know this is 20 and this is 15. He then places this sheet on a mat so that a uniformly wide strip of the mat shows all around the picture. What does that mean? So is the mat bigger or smaller than the picture? Bigger. Here's my picture, and I am placing a mat behind it so that I have the same border showing all the way around. So I have a bigger rectangle going around the outside of this. All right. We don't know how big this is, but I know that it's uniformly wide. That means it's the same distance showing on all four sides. So what could I call that? X. So if you did this in words, X would be the width of the mat that is showing. Is everybody with me to this point? So then it says the perimeter of the mat. Okay, we know perimeter means we add all four sides. But the mat is that outside, and do I have the lengths of those four sides? No, so we have to figure that out. All right, so let's think about my mat. So how far is it from here to here?
X.
X, that's the piece we don't know. How far is it from here to here?
20.
And how far is it from here to here?
X.
So when I put those all together, I have X, a 20, and another X. So what is that total width?
2x plus 20.
2x plus 20. You would have to add all of those together. Okay, so for my height here, from here to here is x. From here to here,
50.
and from here to here,
X.
x. So x and 15 and x would give me Everybody understand where those came from? So now I need the perimeter. So I can't just say it's times 4 this time because it's not a square. But we know we have two sides that have a length of 2x plus 20. And we have two sides with a length of 2x plus 15. So that would give me all four sides, and that equals the perimeter of 102. So now if we distribute, so then we just need to answer the question. X was how wide the strip of the map was showing, and that is the question we are trying to answer. So we can say there will be 4 inches questions about this?
I did it a much different way.
Okay.
I just did 102 divided 4.
So we'll go ahead and stop here for today. If you look on Classroom, I posted 2 things this morning. One of those being the examples. One of them is the assignment. We are not ready for the whole thing. Okay, I want you to do 1 through 4 for tomorrow. So that's defining your variables, writing your equations, answering in a sentence. So you've got 4 problems and